Okay, this is the second video for 1.4 part 1. We're still solving a system with two variables. This time we're going to do elimination. Okay, and eliminate means remove. Okay, so this method works by removing a variable until there is only one left. So when you have the two equations, you stack them on top of each other, making sure the x's line up, the y's line up, and then equals the constant. Okay. And you multiply one or both equations by a constant so that when added together, one of the variables adds up to 0. Okay? Then you solve for the remaining variable, and then you substitute that in to get your last variable. Okay, so let's give that a try here. All right, so I want to look at these two equations are lined up. I have my x's lined up, y's lined up, constants lined up. Okay, in the same position. And I want to see what would be easiest if I add them up and a variable goes away. Well, in this case, I don't even need to multiply by anything. If I were to add these two equations up, the x's actually cancel to 0, or add up to 0. So then I have positive 4y plus 6y, so I'm going to get 10y. And I have 6 plus 24 is 30. So if you think of it like this, I'm taking all of this and I'm adding it to that top equation. Okay? So I end up with 10y equals 30. I'm going to divide both sides by 10, and I already get my answer for y. Okay? Now that's only part of the answer. We now need the x. So I need to plug this into one of my original equations. I'll just pick the one on top. And so I have 3x plus 4, and instead of writing y, I'm going to put what I said it equals, and that's 3 equals 6. Okay, so 3x plus 12 equals 6. Subtract 12 to both sides. So 3x equals negative 6. Divide both sides by 3, and I get x is negative 2. You do not leave your answer like this. You need to write your answer as a point. So that means if I were to graph both of these equations, they would intersect at the point negative 2, 3. All right, let's come over to number 4. All right, now I can look, they are lined up. X's are above X's, Y's above Y's, constants there. But if I go to directly add these up immediately, nothing will cancel out. But I look, okay, top equation, the X is positive. And the bottom equation, the x is negative. So I don't need to multiply by a negative number, but I'm going to take this top equation and I'm going to I want 4x, because 4x plus a negative 4x will add up to 0. So I'm going to multiply this whole top equation by 4, and I'm going to rewrite it. So 4 times x is 4x, 4 times y is 4y, and then 4 times negative 7 is a negative 28. Okay, I left the second equation the same, so I'm just going to write it back out. Now I can add up the equations. Now when I add these up, well, that adds up to 0, that adds up to 0, and that adds up to 0. So I end up with 0 equals 0. That is a true statement, so that means this has infinite solutions. Okay. Remember when we did substitution, we talked about if those numbers don't equal, then it's no solution. If they do equal, it's infinite solutions. Okay? And if you were to continue this through, you might have had to do this step where we multiplied one of the equations, but then you would treat it the same way we did over here. Okay? So now that you've done elimination, in the practice on Canvas, do problems 5 through 8.